Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's webinar by Asia Water 2020, entitled Water Solutions for the Agribusiness, brought to you by the Netherlands Embassy in Malaysia, together with the Netherlands Water Partnership. Before we officially begin, please take note of the following reminders. All microphones and videos of the attendees will be automatically muted. If you have any questions to our speakers, please type it on the Q&A box, which you can see at the control panel section on your screen. We will select a few questions that our speakers could answer during the Q&A session. Should there be any internet disruption during the session, please be patient in trying to sign in again. In the next few days after this webinar, we will be sending you the recording of the session, as well as the copy of the presenter slides. Today's webinar will be moderated by none other than Ms. Ranska Verroes. Ms. Verroes graduated from Combined Master Program Industrial Ecology at Leiden University and the TU Delft with a thesis on recovery of nutrients in the water cycle. At the Netherlands Water Partnership, she connects Dutch and international experts in the water sector with a focus on water and agri-food, as she believes that good water management is the basis for sustainable food production. The Nutrient Platform is a cross-sectoral network of Dutch organizations that believe in a pragmatic approach towards nutrient scarcity. The members, which are frontrunners from the water sector, agriculture, waste sector and chemical industry, several knowledge institutes and two ministries, have joined forces to close nutrient cycles and create a market for recycled nutrients. Ladies and gentlemen, please welcome Ms. Ranska Verroes.
Thank you. Thank you for this kind introduction. And a warm welcome to all of you. The Netherlands Embassy Malaysia, together with the Netherlands Water Partnership, is pleased to have you, everyone, at this webinar on water solutions for the agribusiness. How could Dutch innovations in water management technologies enable more efficient and increased food production in the Asian countries? So it's an honor that I can present, or at least moderate, this session. We have a very distinguished panel of speakers who will share their insights on the latest development in the Netherlands and the Asian region, featuring highlights and the latest innovations by stakeholders operating in the Dutch water and agriculture sector. But before we proceed with the presentations, I would like to give Mr. Jelle Beekma, he's a senior water resources specialist at the Asian Development Bank, the opportunity to give his welcome remarks to all of you. So please, Mr. Jelle Beekma, let me hear your words.
Thank you very much, Renske, and thank you to everybody for being able to attend today. I think this is a very interesting topic that aligns very well also with the Asian Development Bank, where I'm working for at the moment in food security and water. It aligns very well with the 2030 strategy, which of course we have for the Asian Development Bank as well, and particularly the operational priorities. I think then, is the next slide or not? Yeah. So the water solutions for the agribusiness, of course, one of the things that I mentioned already, it aligns well with our strategy 2030, in which private sector is going to play an ever more important role. And of course, the remaining pockets of poverty in Asia, to solve those is very much related to agriculture, because most of the poor people live in the rural areas. And then we have also a special operational priority on rural development and food security, as well as, of course, on climate change and environment. So one of the big challenges that we're looking at is how to increase water productivity while also improving incomes. And if you see on the bottom of my slide, there's a graph that shows how water productivity is increasing in terms of cubic meter per kilogram per cubic meter, but at the same time reaching a sort of flat and then not producing anything more. So a farmer obviously wants the maximum sort of yields, whereas if you go to the maximum yields, you see that water productivity is getting a bit lower. So what can we do about that? Some of these solutions are increased automation, remote management, and digital solutions, and those have become even more important now with the COVID-19, because that would involve less personal management and person-to-person contact. Another, and the Netherlands has of course done a lot in that, there's also a lot of data needed, in which the Netherlands again is a sort of front runner. Then there's circular water and resources use, and it comes to no surprise that greenhouse technology, where the Netherlands is very much of a front runner as well, can help in that, can actually make sure that what we normally lose to evaporation and transpiration is not lost, but recycled. And the same, of course, nutrients can be recycled as well. Then a very important thing is 50% of our food production we're actually still losing after harvest. So post-harvest losses can be reduced by post-harvest technologies, and I think we're going to hear something about it as well. As a last point, we have to keep on increasing inclusivity and women representation, particularly also because there's a strong feminization going on in many of the Asian countries. So thank you very much for having these short opening words, and please over to Renske and the other panel speakers. Thank you.
Thank you very much, Mr. Jellebema. It's wonderful to see how that an organization like yours participates here, and your type of organizations are really needed to support the implementation of these solutions that you just mentioned. So now we're going on to the presentation. So our first presenter, she's an assistant professor in the Department of Water Resource Engineering. She works at the Kaiserslautern University in Bangkok in Thailand. She has 21 years of experience in the hydrological field related to rainfall and flow estimations for water resources management, hydrologic and hydrodynamic modeling for flood mitigation. The main focus of her research is to investigate how radar technology can assess high-resolution rainfall for flood warning and forecasting procedure. Her most recent focus are hydrological observations and monitoring networks. So please welcome Dr. Pumpin Patraska Mapiang. Hi, Dr. Pumpin.
Hi, Ms. Renske. Thank you very much for your introduction.
You're welcome. I would like, before to start with your presentation, I think it will be interesting to know who's actually your audience. So therefore, we will first start with a poll question, and after that, I'll give the floor to you. So the first polling question for our audience is, what is the nature of your profession? So please select one of the options and remember to click on the submit button. So are you working in agriculture business? Maybe perhaps you're farming. Maybe you're a technology provider providing solutions, or consultancy giving advice. Are you working for government or working for an NGO or a semi-public organization? Or maybe you work in some other field. I'll give you a couple of seconds. And I hope that by now, most of you have already shared their votes. So I think now we can look at the results. Well, the majority of you is actually providing solutions or a consultant, but I'm glad to see all of the sectors that I mentioned are represented here. Now we have an idea to who we're talking. Dr. Pumpin, please start your presentation and let us know what you know.
Okay, thank you very much, Mr. Renske. And good afternoon, everybody from Thailand. Thank you very much for having me here in this event. The topic that I would like to share with you all today is how does the Dutch innovations mean for hydrometeorological data collection and agricultural water management in Thailand? Next, please. Before going into the details, let's start with a simple question that why is hydrometeorological data collection important? This is because rainfall and runoff data are crucial water supply inputs for agricultural water management. If we know amount of rainfall and know how much water is available in the river, we can compare this to sources of water supply with water demand in the field for more efficient in agricultural water management. Next, please. The next question is that how to know whether the water supply is sufficient or not. The answer is you have to measure the data. If you need to know how much rainfall, just install the rain gauge on the ground in your own area as much as possible, and also install the staff gauge in the river or in the storage that you need, and later convert the measured water level data into water volume. So you can obtain two sources of water supply. Next, please. Unfortunately, it is impossible to install a very dense measuring network for every location in Thailand. We have rain gauge density ranging between 200 to 700 square kilometers per one gauge. Based on the limitation on data measuring in the country, this quite poor density of measurement in some area could lead to a mistake in water management if the ungauged area has high variation of rainfall and runoff behavior. Next, please. So, citizen science measurements would be an excited optional solution to increase the density of measuring networks. If we can ask help from local people to measure rainfall, water level, or even water quality in different locations covering our field, it would directly benefit the agricultural water management. Next, please. And how can Dutch innovation help measure? What we have been looking for is an easily accessible and reliable technology for local people to learn and measure. Many thanks to Delft University of Technology and for introducing the mobile application technologies developed by MWM mobile water management company in the Netherlands for application in some places of Thailand. Next, please. Let's see the MWM principle. This is a mobile application technology, so we have to start with the measurement first. People can easily just download the application in both iOS or Android system and install in their own mobile phone. And next, just start measuring by taking the picture from the rain gauge or staff gauge. The picture will automatically send to the cloud, and the app will be convert the picture into the digital data. Both digital and image data will be translated and stored in the database and could be displayed in MWM's dashboard. We can finally download the analyzed data for integrating with the hydrological information system of your choice. Next, please. Let me show you some example of implementation of the application in Thailand. In the collaboration with TU Delft and MWM, we initiated the project testing mobile app-based data gathering in Phetchaburi River Basin, Thailand, and possible applications during February to April 2018. We built and installed staff gauge along the river ourselves. We tested the performance of the apps by comparing the data with the government observation, and we found that it's a cheap equipment with reliable measurement, easy to use and easy to share. Next, please. In continuous collaboration with TU Delft and MWM, we moved to another basin of Thailand located in eastern Thailand to test the ability of rain gauge measurement, and we successfully expand the rain gauge density covering the Sati area. We keep contacting with local people for measuring the data since September 2018 until now. Next, please. So, the final thing that I would like to talk is of the opportunities for integrating the CS data with agricultural water management. Since the CS data is not automatic recording, we should integrate the data with advanced technology such as weather radar for obtaining high resolution of rainfall in terms of temporal and spatial resolution. And we can put this high quality of data into the mathematical model for runoff simulation in any place that we need to know the water supply. This high quality data could finally improve the accuracy of agricultural water management in the future. Next, please. And thank you very much for your attention and your time.
Thank you, Dr. Pempin, for this presentation. I can understand that maybe people have some questions, but we will do that at the end. So if people have some questions for you or for the other speakers later on, please put them in the chat, and then also say if it's directed to a certain speaker, to who you want to direct the question. Dr. Pempin, thank you for your presentation for now, and maybe see you later during the discussion.
See you later.
So our next presenter started his journey in horticulture at the age of 23 when he co-founded DATT, a company that became well known for the tomato brand Take Me Home Tomatoes in Thailand. With limited resources and a lot of struggle to keep his plants alive and ensure production year-round, that company started to innovate the way crops are grown in greenhouses in Thailand and surrounding countries. With proven concept, Mr. Keppel started sharing know-how and expertise to other companies. Please welcome Mr. Keppel.
Hello, everybody, and thank you for tuning in. My name is Menno Keppel, and I present you from Thailand in Chiang Mai. So that's in the north of Thailand. Next slide, please.
Well, Mr. Keppel, before we will go to your presentation, I would like to know maybe the reason why the people joined this session. So we'll first have a quick poll question to the audience. So why did you decide to attend this webinar? Again, you can choose one of the following answers and then press submit. So did you want to learn new things, or did you want to see who's around, seeking innovative solutions like maybe that Mr. Keppel will present, or you're interested in all of above? Okay, you have a couple of sessions. These poll questions will go very quickly, so please present us the results. Okay, most of you want to know all of the above, and especially learn new things or seeking innovative solutions. And I think Mr. Keppel will be the right one to present about this. So Mr. Menno, please go ahead.
Yes, thank you very much. Okay, so next slide, please. So my name is Menno Keppel, and I started in Thailand, and this was in Chiang Mai. And we became, along the way, the top grower for tomatoes with a brand Take Me Home Tomatoes in Thailand. And I want to share a little bit of my know-how that I've gained in the last 15 years by a lot of failure, error, and then picking up to a next level of growing here in Southeast Asia. Next slide, please. So our company, when we were founded as a tomato grower, we had a lot of problems. We started solving those problems by adapting to local situation, where from Holland it's very cold. The seasons are different from Southeast Asia, and we saw that some of the technology we imported worked, some of them not. Some of the local situations gave us the idea that we should change and make a change for how the way we grow and the way we treated the plants. And by that success, most of the people that visited us asked us, can we buy this? Can you also supply this? And this is how our company ASA started, Agri Solutions Asia, and we started opening doors for other companies to have agri success. Next slide, please. So our main focus today is about water. So I will highlight a little bit what we do for water technology in Southeast Asia. Our company solves water problems by having water silos. So we advise most of the growers to have a 3-day minimum stock. And we do this with simple silos like you see here, where we store a minimum of, well, it can be under 50 cube, but minimum is 50,000 liters to make it affordable. And then we build them till yeah, 1 million liters. And the golden rule here is to have 3 days stock. Next slide, please. So for our company, many people ask us, you know, we want to grow, and I ask them, why do you want to grow? If you can't be successful and make money, you're not going to be successful in growing. Why don't you make it successful? And so we help people with the concept where you would not only be able to grow but also make money, which is if I don't know if there's any growers here joining today, but it's very difficult to make money in business, and that goes the same for agribusiness. So most people choose to have a proof of setup, and that's what our company has with the experience of tomato growing. Next slide, please. So what we do is actually control the climate inside the greenhouse, and we also irrigate. So for that, we use a irrigation unit that gives us a flexible solution to irrigate whenever the plant needs it, not because we find it needed at 9 o'clock, but because of sunlight, because of the amount of radiation from the sun. Next slide, please. And in this sheet, you can see here that we use drip irrigation. So on the left side of your screen, you see a gutter system that collects the rainwater, where the plant is on top of a bag, or in this case, a slab. The drip irrigation is irrigated by the irrigation unit that you control from a simple computer that you see in the middle of your screen. And on the right side, you see our box, which is a climate computer inside that measures your temperature, your radiation. And based on the information that you put in, you can then start manipulating your plant. Instead of not knowing what is going on, you now have data, and you can take over control over your production. The irrigation unit on the bottom of your screen in the middle has a silo, a tank in there, where we mix the fertilizers. So all the fertilizer levels are balanced and are optimized for the plant. Next slide, please. So for our company, when we use the gutters, we recollect the drain. We use that through a simple filter system again. We then mix that with your rainwater or government water, what you have. And so in that way, we solve wastage. So we have 100% usage of water and no waste. And in that way, you can drip irrigate. You can really precisely give the plant what it needs without wasting water. And these installations are sometimes a little bit more expensive than just the irrigation. But with this solution, next slide, please. With this solution, we also can control the temperature inside. And so with all the controls here, you also be able to invest more and to make more inside your greenhouse because you have plant control. Next slide, please. So the question to you all is, if you grow, can you manipulate your plant? And if you are not be able to say that, then you probably are, but maybe not in a positive way. And what we want really, and this is a picture here in our farm, is that you can manipulate the plant and make money. Next slide, please. And so if you can manipulate the plant, you can also add light, you can add CO2, you have far more control, and you become a top grower in Southeast Asia. And our company gives more simple solutions. Next slide, please. For simpler startups, but also turnkey. So we adapt Dutch horticulture. We try to help you to manipulate your plant from start, so you don't have to make the beginners or startup mistakes. And we help you to do it turnkey. But I think with this whole water situation that we have in Southeast Asia, the most important is that we make produce locally possible, and especially with the COVID. And so if you need any water solutions, I think in Southeast Asia, we have many companies that can help you. And we hope that with this seminar, we can all save more water and be successful in horticulture. Next slide, please. That was my presentation for now. I hope I did it quite clear for you, but in case you have any questions, please reach out to me. I'm happy to help you further. Thank you.
Thank you, Mr. Menno. I think you mentioned some important points, also like the challenge of implementing Dutch technologies in a different environment. And I hope maybe we can come back to this question in the discussion later. Thank you.
Thank you.
So our third speaker is a business manager in water and agriculture at Nelen and Schuurmans. He's a senior consultant and project manager with a broad experience, both national and international projects. He's leading a specialized team of consultants, and he has shaped Nelen and Schuurmans' contribution to the agricultural domain. And this includes various Southeast Asian countries, like in Cambodia, Philippines, Indonesia, and Vietnam. So please welcome Mr. Alexander Hof. Hi, Alexander.
Thank you, Renske, for introducing me.
Just as the previous speakers, before we go into your presentation, we'll have a quick poll question. So the question for you, for the audience is, how often do you look at the weather app on your phone? Would it be not more than once a week, or maybe even multiple times per week? Or do you really want to be prepared and look at least once per day to check what's the weather outside? All right. I hope you had time to submit your vote. And now let's look at the results. Okay, this is very varying. I think, well, most of you multiple times per week. So I think that this is very interesting to see, and people do want to know what's the weather outside. So Alexander, please tell us what you do and why this question relates to your presentation.
Yes, thanks again, Renske. And good day, everyone. It's nice to be here, although from home during these particular circumstances. So my name is Alexander Hof, and I work for Nelen and Schuurmans, a Dutch firm on water and IT. We make information services. And it's good to recognize that a lot of people are using weather apps such frequently, because that's in essence what we do as well. Next slide, please. So Nelen and Schuurmans is a Dutch firm. We're specialized in water and information technology. We are a SME, a small medium enterprise from Utrecht in the Netherlands. We make innovative software and implement this in various cases. I will leave it at that, and I would like to explain you why this is what we do. Next slide, please. So I don't need to explain to you about the challenges that the world is facing. Climate change leading to more natural disasters and constraints. Too much water is leading to floods. Too little is leading to droughts. In short, you could consider this as a disbalance between what we actually need in the world on water resources and what the world is giving to us. And while we can solve this limitedness of resources, what we aim to do is to help other people making better use of these resources to create more of that. And in agriculture, this means practically more production of crops with limited use of water. Next slide, please. So our mission is to allow water managers, agribusinesses, and farmers to make smarter decisions using data. And we use data analytics and our tools to create information systems about the physical world to do this. The weather app we started with is an example of a decision support system, of an information service that many people use, and a lot of you also use every day. If you want to go outside, you look at your app to determine whether you should bring an umbrella or not. And although it's not always right. It can be very convenient to make the decision you need to make a little bit more informed. And this is in essence what we do with our software. And in this presentation, I would like to explain to you our approach to this. Next slide, please. So luckily, we are not alone. In these days, we measure everything in the world. And our two previous speakers also explicitly stated their approaches to getting data on water and agriculture as well. For example, across the globe, there are dozens of satellites that measure every square meter of the Earth every day. And there's so much data being produced every day. And one of the things that's particular about this is that 90% of the data that's available in the world today has been produced only in the last 2 years. So the challenge actually has shifted from the data itself to trying to make use of this, the maximum use of this data. And this is where we focus on as a firm. The use of data for your analysis requires integration and system analysis. And integration means that this data is scattered and distributed between various data sources in various shapes, in various locations, in a very unstructured way. By integrated these data sources, not only on a one-time basis, but also in a live connection. And they are put together to create a systems overview to have the best possible data about what's happening around you in the field of water and agriculture. This allows for advanced system analysis or big data analysis on this data. For example, if you're looking at irrigation systems in agriculture, you want to use satellite observations that tell you about plant growth and water resources, while topographical information about the canals is very important to know how the water is flowing. At the same time, the farmer and other people in the field make measurements and observations as well that are very important, all to integrate an analysis to create a system overview. So the final step is not only to do this analysis, but to create decision support systems that allow users to make smarter decisions. Although this is a trivial step in many classic work, the intelligence remains in the analysis or in the tools itself. And making this available to the end user is an important step in that. So these could be online web portals, dashboards, or smartphone apps. And an important key is that this whole chain, this whole information chain from data to analysis to decision support remains intact, so that every time the user needs to make a decision, this decision can be supported by the best available data. Next slide, please. So in the past few years, we've implemented numerous solutions to achieve this, particularly in Asian and Southeast Asian countries. And the slide shows some of our project examples that we did in Bangladesh, Vietnam, Cambodia, Indonesia. We've created solutions for private partners and governments, for water managers, for agribusinesses, but also a lot for smallholder farmers. And in order to organize this, we've also recently opened up a branch office in Taiwan to be a little bit more in the region itself. Next slide, please. So on this final slide, I included a range of solutions that we have developed. This ranges from smartphone apps to dashboards to web portals to voice information systems. The key takeaway message that I want to give to the audience today is that the eventual decision support should be dialed in to the needs of the users. So just like you want to use a weather app that is very easy and convenient for you, if you work for smallholder farmers, the information needs to be very accessible, very easy, understandable, and very low entry, while water managers, professional water managers, require more sophisticated decision support systems. That's our story, and I would like to thank you for your attention. If you have any questions, feel free to put them in the chat or reach out to me anytime. Thank you.
Thank you, Mr. Alexander. And I think it's very valuable to know what the weather's going to do. I think that most of us has experienced the moment that you went home through the rain, coming home, and by that time it's dry again. So you know you could have waited a bit more. So for now, I would like to move on to our last speaker, and I will keep some of the questions for you later, Alexander. Everybody speaks here very enthusiastic. So Jan, I hope you will be able to stay in time for your presentations, because our final presenter, as I already said, Mr. Jan Slange, he's an extended international experience, or he has extended international experience in water and wastewater projects for agri-food, petrochemical, paper and pulp and steel industries, quite broad. He participated in industrial wastewater projects for slaughterhouses and its byproducts, like the gelatin industries, in Europe, Asia, and South America. Besides wastewater treatment, he advised several industries on water saving, effluent recycling, pollution prevention, resource and energy recovery, and sustainable solutions. He's involved in several projects in Southeast Asia. Hi, Mr. Jan.
Hello, Renske. Thank you for your introduction.
Yes, shall we, before we start your presentation, have our last question to the audience? Because ensuring good sustainable water management in business, what does that mean to you as an audience? Would it be cost savings because it equals more profitability? Would you like to build strong business reputation that cares about the environment? Or do you think it means being legally compliant to the environment protection laws? Or to you, it's all of the above? So let us know your answer and press the submit button to vote. Thank you. Okay, well, let me see what our quick audience said about this poll. Oh, it's good to hear that most of you value all of that. So therefore, for our last presentation, I would like to give the word to you, Mr. Jan.
Yes, thank you very much, Renske. Yes, as we all know, and the previous speaker also informed about that, agriculture or many industries need water for growing the crops or even the production. But finally, in the production, one of the, of course, the main product is the product to be sold, and the byproduct is wastewater. But we see the wastewater also as a resource. I would like to share some information of you of the projects we did or we still involved in the palm oil industry in Indonesia, from our office in Indonesia. Next slide, please. Yeah. So I will touch two subjects. One is the production of palm oil mill effluent, and finally, to make the closed circle, recycling of the effluent. Next slide, please. Yeah, this is a slide which I focus only on the palm oil mill effluent, called POME, as one of the big byproducts in the palm oil industry. The volume is approximately 60% of the tons fresh fruit bunch processed. And currently, in many countries, Malaysia, Indonesia, and Vietnam, Thailand, palm oil mill effluent is treated in large open anaerobic lagoons. This causes CH4 biogas production and contributes largely to the greenhouse gas emissions. After the anaerobic lagoon, there is a aerobic treatment with air to meet the discharge requirements, which are different in many countries. Also, some wastewater is used for land application, which goes to the plantation. Only less than 10% of the mills capture biogas generated, and usually they do in covered lagoons. You see the example of the covered lagoon in the picture in the right corner at the bottom. And if you do in what we call reactor tanks are a bit more efficient. The biogas is still, in most of the cases, flared. So once you reduce the greenhouse gas emissions, you don't make use of the renewable energy. The palm oil mill composition differs a lot depending on the type of mill, small, old, technology, many pre-treatment or no pre-treatment. And I put these discharge standards, which are not all right now valid in many countries, but for the near future, we have to think about meeting at least this discharge qualities. Next slide, please. So the more stringent discharge requirement requires treatment. And first of all, the anaerobic treatment is a good technology. It saves energy, it produces energy, and it can be done in various ways. Here you see the three types of anaerobic treatment, which one is the covered lagoon. It uses large plot space, but is low in cost and low efficient. The continuous stirred tank reactor has a higher efficiency and is also higher in cost. And then the other one is the IC or another type EGSB reactor. That's only suitable for when you remove the suspended solids. It has a short retention time, therefore it's just a smaller volume. Yeah. Next slide, please. Yeah, then we come to the water use. How much water is a mill using? Typically, we found for all the mills we investigated between 0.6 and 2.0 cubic meter per ton FFB. Usually they extract the water from surface water as the main source, river or lakes, and very few are on artificial reservoirs, groundwater. But what we see that the quality and even also the quantity you can extract varies during the year. Sometimes in rainy season, a lot of suspended solids in the water, and in dry seasons, even too little water. Too little, so that they have to reduce the capacity of the mill or look for other sources. The main water use is in the palm oil mill is steam, production of steam, and therefore you need quite clean water. And therefore every mill has its own water treatment plant to produce the boiler feed water, including reverse osmosis with membranes. In all the plants we visited, there is no or hardly no reuse of treated POME, mainly because the quality after treatment is still not sufficient. It is sufficient for discharge, but not sufficient to produce reverse osmosis or to produce boiler feed water, but there is also no experience how to treat up to boiler feed water. In fact, it's possible to have a zero discharge and reuse all the treated POME to produce boiler feed water and other technical water. Next, please. Yeah. This is an example we have already built 10 years ago. It's an operation where we focus on the production of boiler feed water with very low dosing of chemicals and limited cleaning of the ROs. Cleaning of the RO is usually required because of the biofouling on the membranes. We developed the system mainly with focus to prevent the biofouling and to increase the lifetime of the membranes to save the costs. Next sheet, please. Yeah. This is how how the process configuration of the effluent recycling plant looks like. This is for a quite large capacity. You see the intake is 11,200 cubic meter per day. Therefore, you see multiple trains. That's not required because the palm oil mills have a smaller capacity. We use the treated effluent with the quality for discharge. And the first step is what we applied is a submerged ultrafiltration. Then we have what we call BACF. It's a biological activated carbon filter. And afterwards, the RO, and in this case, we used 2 double pass RO, but in many cases, 1 pass RO is sufficient. Next slide, please. This is the result of the test with and without the biological activated carbon. We see that this is the cartridge filter just before the reverse osmosis, and without the biological activated carbon filter, the cartridge filter were dirty very quickly. And using the biological activated carbon filter, no fouling on the cartridge filter was observed. So the biological activated carbon works perfect and prevents already fouling on the biological cartridge filters. Next slide. And this is because the biological activated carbon removes all easily biodegradable carbon, BOD, COD, and oxidized ammonia present in the effluent. It's lowering the growth of the concentration of the growth-limiting substrate like BOD and nitrogen. So there is no substrate for any bacteria in the RO feedwater. How do we operate this biological activated carbon? Because we want to grow a biofilm on the biological activated carbon. The biological activated carbon is not used for removal of suspended solids. It's only used to attach biofilm on the activated carbon. We backwash only once or 2 times a week, and we have the second stage is BACF is only once a week. We only dose antiscalant, and no biocide dosing has been used for the past 10 years. And the CIP frequency of the RO's membranes is 2 to 3 times a year, only with caustic or hydrochloric acid. When we designed this plant, we estimated the lifetime of the membranes about 8 years. Currently, it's already 10 years, and expectations are that we can use the RO membranes even for a period of beyond 15 years. Next slide, please. Thank you. Thank you for your attention. This system is not only applicable for palm oil mills, but also for other industrial processes.
Well, thank you, Han, for your presentation. I think this was especially interesting for the people with a good technical background, because you really explain all the technology. And it's an interesting case to look at the water reuse instead of not saving it, but reusing the water. So this is a moment we still have some time for questions, and we received already some, but if you have an additional question, please share them in the chat box. So the first question I would like to say is to Dr. Panpim. So I had a question, does the technology apply to the dry season with limited water?
Okay, thank you for the question. I'm gonna say yes for the answer, because this technology is a mobile application. You can use this technology all the time that you need. But it should be noted that in dry season there is no rain, so it is necessary to measure the rain gauge, the rainfall. But the important thing is that the source of water supply you come from the water in the storage, in the river or in the lake or in the reservoir. So it's still important to measure the data, just only the water level. Data using the staff gauge and using the application for monitoring the water level. In this case, I think this technology can really help for constructing the monitoring network or relevant storage. Not only in your area, but in a nearby area, you can measure the data and set up as a network. So you will know when, where, and how much water is available. This definitely benefit the water management, from my opinion.
Thank you. I think that will be a clear answer. So I have another question for Dr. Menno, Mr. Menno. Do you measure moisture or soil to control the drip? This is a question from Mr. Han.
Well, it depends on the option that the farmer or grower selects, but we can do both. So we can do water content measurement inside the soil and both in the slab. And so we have that as a control to give a start to the irrigation unit. I have to add, if you only have one sensor, that would not be recommended. To have multiple sensors in the same area will protect you from, if your sensor is off, that the irrigation will run. So the answer would be to have multiple, not only one sensor, but multiple sensors in one and the same area.
Thank you, Mr. Menno. I think that is also a clear answer. If the person, if Mr. Hang still has another question, he can put it in the chat again. So I had a question also for Jan. The question was, what is the most effective and best technology in treating wastewater from the food, beverage, and agribusiness industry? You just mentioned one of the technologies. Do you have any others, or do you think that this is one of the best?
Yeah, thank you for this question. Very interesting question. Yeah, in general, I would say biological treatment is the best and most effective way of treatment of wastewater from agriculture, of agri-food industry. However, we make a differentiation between anaerobic and aerobic. Anaerobic is without you produce biogas. It's only applicable with high concentrated wastewater streams. With low concentrated wastewater streams, you should focus on aerobic treatment, which is the conventional activated sludge, moving bed biofilm reactor, or sequencing beds reactor, are still the best systems.
Thank you. I have another question for Mr. Alexander. One of the questions is related to Internet of Things in the agricultural water management system. So what is the role of the Internet of Things? And addition maybe to that, is Internet needed for all the data that you send? Oh, I think you're still muted by the organization. Please try again.
Yes, now I'm unmuted. Thanks. So there are two parts to the answer to this question. I think firstly, the Internet of Things is one of the developments in line with the fact that we measure everything these days. So actually, smart devices are a very important input to making better decisions. So this could be cheap sensors put in the field, or weather stations, or any other devices that is able to send a message. The other side to the answer to this question is the internet connectivity of that. One of the things that you see today is that almost every sensor is connected in real time through internet or 4G or mobile connections. which allows you to give very up-to-date data on what the actual status is. And even a few years ago, also professional measuring stations needed to be read by hand by someone traveling to the sensor, connecting it to a laptop. So this is a development that is rapidly benefiting smart decision making.
Thank you. Thank you. All right. I see we have officially 2 minutes left, but I have 3 more questions, which I think are very interesting. So I hope the audience finds it interesting enough to also stay 2 more minutes afterwards. So one question to Jan is, can the BACF system manage also liquid waste effluent from a pig farming?
It can only applicable to treated wastewater. Yeah, it should at least meet the normal discharge requirements. Then it can be used. It is typically used or applied for removing the remaining low concentrations of BOD and nitrogen. So not immediately for liquid from pig farms.
Thank you. I think there are alternative systems I also know in the Netherlands that can address maybe the manure itself. So almost last question is to Mr. Menno. How much cost per square meter of using the water control systems, or what are the costs per square meter of using the water control system, and the estimated payback period?
I think the estimated payback is about a few months, but you do need to have skill on that. So the systems that we generally sell are more high tech, and they are for larger farms. So larger farms, I would say maybe four greenhouses or more. I have to add to that that I assume that you do not have an irrigation unit now, so you will have plant loss that you can solve by having this system. So I can only speak for myself. I returned it in, I think, 1 year, the money, and it was because I reduced plant loss by 30%, and that just came from giving the plant what it needed. But that doesn't give you the answer on investment, and that doesn't give you the answer on square meter price. But if I ask you how much you can save with 30% more plants or 30% less plant loss, I think you can actually answer it for yourself. And in terms of small farmers, because that's also a thing, I don't want to sell something high tech to somebody who's not ready for that. So what we do is we have 3 solutions that start from a small investment of €1,500 and going up to the next level. And then you end up around €7,500, and then after that it's unlimited because that doesn't stop. So it depends a little bit on your size. But reach out for me personally, and then I'll help you with the investment cost based on your needs.
Thank you. Okay, I see now, although our time is up, I see many questions coming in. So I just want to know that, want to tell you that these questions, we will ask them later to our panelists to answer. Some of the questions include, like, what is the most efficient anaerobic technology suitable for palm oil? Questions about various initiatives to a physical or chemical treatment process. But all these questions, we cannot address them at this moment, but we will make sure that these questions are answered and reported back to you. So the last question that I would like to ask is, maybe start with Dr. Pim, is what are the panel's views on pollution due to agriculture? How can rivers be better protected to it? Dr. Pim, do you have a reaction on this question?
I'm not related with the water quality, so I'm just for me, water quantity is my field. So I'm not quite sure about this question.
That's okay.
Yeah.
Does one of the other panels would like to react on that question, like how can rivers be better protected against this pollution by agriculture?
Well, I think one of the things that we need to look more and more into is these sort of circular economies and circular systems, in which we try to use the wastes that we have either as, for example, a fertilizer or a manure, or even better, in which we try to catch them and reuse them. And there are many opportunities for that. I think also dosing much better the amounts of fertilizer, for example, that you need is an important development, as well as maybe going much more to biopesticides. Thank you.
Thank you, Jelle. And actually, I think that the work that you all follow does somehow relate to this question, because maybe it can help to do farming inside greenhouses. It's important to know where this pollution is coming from. So the sensoring and knowing about data is important. We want to know whether the pollution goes into the soil or straight away into the river, or maybe we can rebuild the area to prevent this runoff. And of course, also don't put, let's say, polluted effluent into the rivers, but make sure that we treat it in a nice way. So actually, I think all of you support this and help keeping the rivers safe. So with this last question, I would like to conclude this webinar. Really thanks to all you as the speakers, and also to the organization for organizing this webinar. In the next few days after this webinar, we will be sending you the recording of the session and a copy of the presenter slides and a survey form, and I hope you will help us by answering this. So thank you for all your attention, and have a great day, evening, morning from wherever you are.
Thank you.
Bye.
Bye-bye. Thank you.
Thank you.
Bye-bye. Thanks a lot.
For the last ones, pre-register now and visit the Netherlands Embassy booth at Asia Water 2020 virtual event on November 3rd to December 2. Just visit the website www.virtual.asiawater.org, and we hope to see you there. Have a great day and stay safe.